everyone, this video clip introduces the electronic motor starting switch and discusses its technical advantages over conventional types of various motor starting mechanisms that are widely used today. The single-phase AC motors are the most common motors used in many electrical home and commercial appliances. The main advantages of AC motors are its simple and rugged design, least expensive cost, lowest maintenance, and the ability to directly connect to an AC power source. The single-phase induction motor does not automatically start without a starter when the motor is connected to a power supply. The starter of the motor is mainly an additional starter coil, a series capacitor, and/or a starting switch. The magnetic interaction or phase current difference between the main coil and the auxiliary coil generates rotating magnetic fields. Single-phase induction motors are further classified depending on various starting techniques. Four most common types are RSIR, CSIR, CSCR, and PSC. However, if the starting torque needs to be bigger or equal to the full rated torque, you may have to select either a split-phase motor or a capacitor start motor. Both motors require starting switches as described in the drawing. Once the motor reaches about 70 to 80% of its rated speed, a starting switch disconnects the starting coil or the starting capacitor in a series from the power source. Then, the motor maintains sufficient torque to operate its own. Now we are ready to discuss the types of starting switches. The most popular starting switches today are centrifugal switches, potential relays, current relays, and PTCR. Each one of them has its own pros and cons. However, I would like to discuss about the list of technical advantages which are very difficult or nearly impossible to find with the previous technology just introduced, but can be easily provided only with SAMUSCO switch. First of all, using a reliable snubberless triac allows extended life for the contacts. The mechanical versions shorten their lifespan due to the degradation of the contact points through electrical sparks and mechanical fatigue. By applying the high-end semiconductor device and not using the rotating part for detecting motor speed, these drawbacks are eliminated, extending the lifespan of the contacts. The mechanical switch has shortcomings like switching noise or vibration. The vibration level becomes very critical to electrical lifespan of the contacts because the number of switching sequences for each starting cycle can increase rapidly as the starting time increases. In addition to this, the innate sounds of the rotating mechanism and/or contact movements were not quite acceptable to some high-quality machine applications where quietness is required. ECS operates only once in every starting cycle without contact movement, guarantees minimal switching noise and/or electrical noise, which adds the most cost-efficient solution to improve the quality of your single-phase motor application. When electricity is turned off while a motor is running, the conventional mechanical switch loses the force around it, which reconnects the contact points, creating an unexpected halt that may cause mechanical stress to joints with bolts and nuts. ECS maintains an open contact while input power is not present by storing the power status in a built-in memory chip. When a rotor fails to start, it does not roll, burning out the motor. In this situation, the starting capacitors also get easily damaged. ECS retains the open contact if the locked rotor time is longer than the preset operating time. Geared motors can often rotate in the opposite direction instantly due to an unexpected mechanical burden. ECS detects and stores the status of the rotating direction. Then, whenever the rotor is in an unwanted direction, it immediately reconnects until it runs to the right direction. Using this function, you could also make your motor be bidirectional by simply adding ECS and a standard relay for swapping motor coils to power connection. ECS is compact-sized and is independent of mounting positions. It can also be installed away from motor coils, so you could design your motor to be much smaller in size without giving up its output power. Usually, the conventional switches are calibrated to individual motor specifications. For example, the numbers of poles, frequency, coil impedance, rated voltage input, low voltage input tolerance, starting current level, starting time delay, output power, and even mounting positions. This entails buyers to study various switches and their part numbers according to each specification. ECS monitors the variation of a motor's starting torque and helps to find the best optimal pointer breakdown torque to switch off the circuit. This feature enables you to adopt a single switch for all your single-phase motors and their applications. By simply using the electronic version of the motor starting switches provided by SAMUSCO, single-phase motors will be much more than what they used to be in terms of improving overall quality, saving cost in many ways, and possibly the extended functions to the bigger market.